Hello, my name is Matthew, and I'm excited to introduce to you a new Print to Perform series on creating a customly fitted airbox to a motorcycle. This series is perfect for people who are trying to create aftermarket parts or trying to understand what tools can be used to create and validate custom components to existing ones. Now, an airbox is designed to drive air into the carburetors. This increases the engine's efficiency. In order to create an airbox that fits perfectly to the Yamaha motorcycle and is optimized to move that air as best as possible, we'll be using different engineering tools at our disposal. This will both speed up our project's timeline and validate our components, making it much easier to print them. The first video in our series will discuss the case study as a whole, what drove us to start this project, and a summarization of the project as well. Starting from the initial hand measurements and what problems arose because of them, to 3D scanning the bike, then using that 3D scan data to design our initial model of the airbox, and then running simulations to find out and optimize that airbox design. Finally, we will print and then validate that part as well. We'll have 2 follow-up videos, which will be in-depth dives into how we created our reference features from that 3D scan data and running our simulations on the airbox. This is to shed light on some of the most important steps within the project and why they were chosen when designing the airbox. Finally, there will be a third video on reverse engineering freeform shapes within SOLIDWORKS using the same tools we used to create our airbox. This way we have a gas tank to incorporate into our future designs as a SOLIDWORKS part file if we so choose. We hope you find these videos informative and give you inspiration on how to improve your current workflows and maybe optimize your designs even further. Subscribe to our channel to stay tuned, and we'll see you there.